Okay, so today we will start with the second unit, I believe. So it's a package, and later on in machine learning, we are going to use also quite a lot. So it's the Numpy package. And I also have the link. This is from Numpy. I believe it's from Numpy official website. It's a quick tutorial. And I also have some, maybe a couple of other information. So I put some reference link also here. And then let's see. So for Numpy, so Numpy package. Okay, it's mostly used for numeric calculation. And if we want to use, we need to import the package, Numpy package. And in Python, if you needed to use certain packages or methods or objects that's not embedded with the Python language itself, then we need to do the import the respective package. And here we import it, and then we can just use this abbreviation for future reference. Okay, so in Python, last unit we learned there is no array, so we use container like list for the number of, for a number of items, collections. And the last unit, we also learned there are some other containers. Is it like a list is changeable? Okay, we also learned tuple, that's immutable. And we also learn dictionary and set. Okay, so those we already learned. So in Python, there is no array, but for Numpy package, it deals with array. Okay, and its array is a class. It's an ND array. Okay, so so this is regarding Numpy. So how do we create a Numpy array, ND array? So we import the Numpy package, and here it shows, so then you can call the array function from the Numpy package. And what here we passed in is what? Is a list. So it can use a list or tuple like here that's be created with the array. Okay, so you pass in a list here, and then we create this array, Numpy array. And also for Numpy array, it's homogeneous. It's not like a dictionary, but dictionary can take different items, but for ND array, it got to be the same type. Okay, and here it's all integer. And over here, we also show, so this is like if you have a variable and put a question mark, and it will give you some detailed explanation about the related objects. So here, if you run it, you will see the output shows, okay, the data type is Numpy ND array, and what the value it is, the shape. So quite a number of information. Okay, so this kind of used like a help function, the question mark, following the variable. Okay, and here we have one array A, and B is also an array. So this time we created with also a list, but this is a floating type of number. And you can also check the array's shape. So here the shape is one dimension. So that's we get. So here it's the first dimension. Okay, so that's we get the shape. And then let's see. And we can also create a two-dimensional array. Okay, so for two-dimensional array, so here what we passed in is what? This is a list. And then within the list, we have tuple, is it? So the list has 2 tuples, and you create the ND array. And this is a 2-dimensional array. So for the 2-dimensional array, if you see the output, then we have the outer brackets, then we have the inner brackets and the comma, and the comma. So this is kind of like you count as a row, as the first dimension, and then this is the second dimension. Okay, so this is the column. Okay, so that's how the 2-dimensional ND array in NumPy output looks like. And over here it shows it can also take complex data type, but that's not our concern. Okay. And what next for NumPy arrays, you can also for NumPy package, it also gives us a couple of functions that you can use to generate some sequence of number. So here it shows one. It's called arrange. Okay, for the arrange, this function, it said generate values with a half open interval. Okay, so the ending part is exclusive. Okay, exclusive. So it's start with 10 and the end at 30. And here is a step. So 30 is exclusive, so not included. So that's why the output is a ND array, 1-dimensional. So you have 10 and the step is 5 and the 20 and 25, but not include 30. So you want to have this range of number be generated. And we can also use floating as that. So here specifies a range. So it's quite flexible. So sometimes we may use that. And for the arrange method, you provide the step. So not the number of items you want the array hold, etc. So this is another function in NumPy, and over here it generates the number. So you can specify number of items in the array. Okay, in there. So here it shows us. So this is another function. So line space. So over here you have start and end. This is start and end. Start and end. Here is the number of items. It's going to be evenly distributed between this range. And over here, if you take a close look, you will find that's inclusive. Okay, so the ending is inclusive. There's just some subtle difference. Okay, and the next one, this is quite important concept with NumPy package, the operation. So here, the arithmetic operation on the array, it applies so element-wise. Okay, so it's element-wise. So we will see that, how that works. So here A, we generate an array. There's 20, 30, 40, 50. And the B, you use that arrange to generate the numbers, the arrange. And over here, if you take a look, we do that 10 times. And also over here, this is A, array A. Array A has 4 items. Then what we do? You do some function. The function apply, so you plug in kind of this array. Is it? So what this will do is it will do element-wise on it. So this will generate an array. And then you do the 10 times. So this you don't need to do individual element for array. In other programming language, what we learned is you need to do this individually, the each element. But here, you don't need to do that. So it's this multiplication directly apply to a NumPy array, element by element. So it will times, because the sign value is less than 1, is it? So then you times 10. So that's how we get values greater than 1, okay? And over here, it's element-wise applied. So 1 by 1. But we don't need to use a loop to do that 1 by 1 operation. So it's directly. So that's the nice part for the NumPy array. Okay, so element Y. And we also, later on, we also will see it's a broadcast rule. And so that we just saw this multiplication. Okay, that's element Y. Be careful. Okay, so that's multiplication. And then for matrix multiplication, the matrix product, etc. So what we can use then is what you can use this at operator, okay, or the dot method. So these two, okay. So that's regarding matrix. And what next is try to explain is this like a plus equal or multiplication equal. And be careful here that they are going to modify the array, okay, not to create a new one. And also over here, so NumPy, you can also call the dot ones. And over here, it's the shape of array. So that means you have 2 rows and a 3rd column array. So 2 by 3, okay, and all ones, okay, it's all ones. And then B, so that's A, it's 2 by 3, it's all 1. So it's always a 2D array. So that's this ones does. And for NumPy, the random object, it also has the random method. So we can also call the random, okay, do some random sampling, okay, generate some random number, okay. And also over here, you specify the shape, okay. So what we can see, the shape is passed in like a tuple, okay. So it's because it's a parenthesis. So that's you specify the shape. And then over here, there's both are 2 by 3, both are 2-dimensional array. Then we do this plus equal, is it? And over here you do times equal, is it? And this is also element wise. So we don't need to use a loop. Is it? This is an array. Okay, array. And if you do this operation, it's automatically do 1 by 1. So 1 times 3 automatically applies to each of it, element wise, okay? So similarly, the plus equal, and if the 2 array are the same shape, then you can do the plus equal, and then you add both together, and we get to the result. And also over here, it's the array itself, B, it's changed, so it's updated. So it's not generated a new array, okay? So that's regarding element-wise operation, okay? And what next is says, sometimes you may want to do some unary operations. Is it like calculate the summation? Is it calculate summation? So let's see, how do we do that? So this random, it's going to generate some random number. But be careful, okay? So this random you plug in with, this it means a shape for your array, okay? And the number, random number is going to be between 0 to 1. And then what over here is you want to do the summation. And if you just call the sum without plugging in the dimension, the axis, then it's going to sum all of the items. So it's a summation for all of the items within the array, okay? And you can also specify summation by what? Is it summation by which axis? So summation by which axis? So the So this is 2 by 3, so 2 row. So A is 2 row, is it? So we have 2 row and 3 column. So that's A. And here you said we want to do the sum. Okay, sum by the first axis. So here axis equals 0. That means the first axis. Okay, the first axis. If we take a look, so this is print. The result is this. Is it changes from from 2 dimension to 1 dimension. You keep the row. Is it you keep the number of columns. Okay, because what? This is summation. The first dimension is what? First axis, it's a row. So you're going to add the row number. So that's why the column, you still have 3 columns, but you reduce the row number to 1 because you add all of the numbers between rows. So that's axis equals to 0, okay? And if you specify axis equals 1, then we can see, then it's summation. Sum the column, okay, and the output you will get for each row, the summation result. So that's why you only have 2 numbers, is it? So it's also, dimension also reduced, okay? So for the sum operation, if you don't specify the axis, it's summation over whatever the array shape. So all elements. And if you specify which axis you want to summation, then it will reduce the dimension for the result. Okay, so that's the sum method. And then next, let's see. So this arrange we already learned. The generator some the number you specify. Okay, arrange. And for Numpy array, and if we just do arrange 12, then it's a 1-dimensional. This is 1-dimensional array. Okay, and we can also call reshape to change the shape of the array. So then it's a change from 1-dimensional to 2-dimensional. So it's 3 by 4, is it? So we have, so this is regarding the first dimension. Is the first, and then you have second dimension as a column. So this is axis is 0. So here is the axis is 1. Okay, the column. But anyway, so the array output, we already see it's 2 dimensions. So you have outer brackets, square bracket, inner square brackets. Okay, and then what next to try to show? Let's see. What does this mean? Okay, and previously in Python, we also learned indexing and slicing. Is it? So indexing for like list is to retrieve single item. Okay, slicing is you are going to retrieve, and it still can be single item, is it? So 1 or more items. Okay, normally when we do indexing, you just specify the specific position of the item you wanted to retrieve. And for slicing, we can use the colon, is it, to specify the range. Okay, and so let's take a look. What does then this mean? The B is a 2-dimensional array. Is a 2-dimensional array, and over here we have the comma. Is it? So for the comma, so this part is regarding the first dimension. And after comma, this is regarding the second dimension. Second dimension. Okay, so for the first dimension, we have dot, dot, dot. For dot, 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 basically for slicing, it's slicing from the beginning all the way to the end. Okay, so everything from the first dimension. So the first dimension is the row, is it? So okay, we'll consider all these 3 rows. But for second dimension, we are going to, so the second dimension, so in this case, this first dimension kind of like slicing. And then for your second dimension, you do indexing. Second dimension is what is the second the second column, etc. So that's why we get the result as 159. Okay, and over here, what it to try to show is later if we see this one. So basically, the dot, 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 and the just a colon without the starting and the ending for the slicing index, these 2 are the same. So that means everything. Okay, so here is the first dimension. You include every row from the first dimension. Okay. Okay, so this is regarding that this I don't think we need to yeah, let's see this one. Okay, so for this one, the mean, it's similar as that sum method. So it does the mean calculation. And here, same thing, you can also specify which dimension you want to. You're going to apply the operation. So here is for the second dimension, you are going to do the mean calculation. And here, same, we already see that. This is you specify the summation for which dimension. Okay. And then let's see. Okay, previously we see that sum, the method sum for the array. Okay, so here is a Numpy array, the sum method. And there is, so here is array B. Okay, so it's 2-dimensional. It's 3 by 4. This is a 3 by 4 ND array. And for Numpy array, you can also apply this method, cumulative summation. Okay, so this is doing the cumulative summation. Cumulative summation, it does on what? It said sum along what? Along each row. Sum along each row. The dimension is, you're going to apply the operation on what? On the column. So this is the second dimension. Second, and then you're going to do summation, but a cumulative summation. So let's say cumulative is you are going to add. So for the first one, there is nothing before it add. So that's why it's still 0. For the second one, then the result is what? You're going to add 0 and it's 0. So that's how you get 1. Okay, and we have 1. So this is new result. Then you are going to add what? Add 2 on top of it. So that's how you come with 3. Is it? Okay, after we have 3, then this is the new result. Then you are going to get the next item you want to add. So that's how we come with 6. Okay, 6. Because this set is what? It's along each row, is it? You're going to do sum on column, but along the row. So the shape will be kept the same. In this case, not like the sum, it changed the shape. So here the shape not changed. And so that's why this 4 is still 4. But for the next one, it's 4 plus 5. So that's how we come with 9. So for the remaining, it's similar. So this is the concept of cumulative summation. Okay. And then next it says universal functions. And basically at the very first cell, we also saw that it's that sign operation, etc. So as NumPy also provide quite a number of mathematical functions like sine, cosine, exponential, etc. Okay, and it says they are called universal functions. Okay, and those functions operate here, and once again, it's element wise. Okay, because it's element wise, so the result is still an array. Okay, still an array. So that's what over here to me. So basically the idea is you apply the operation to a NumPy array, the result is still array. So it's going to, this method is going to apply the element by element. So that's why we call it element wise. Okay, because you see here be arranged. So it's an array with 3 items. Then we apply exponential on it, calculation on it. So that's how you get the result. It will automatically do element by element. Okay, so this is regarding universal functions. Basically, it's mathematical functions for the ND array. And what next is we previously also mentioned, if you recall the dot, 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 or the colon, is it? So discuss indexing, slicing, and how do we do iteration, is it? So let's see, how do we do all of this? And here it also said the slicing, and the slicing we can use the colon that you specify start and stop, and then you can have the third colon. For the third one, then it's a step, because sometimes maybe you don't want to do like the unit step, is it? So you want to specify the step, the step, maybe every 2 or every 3 kind of slicing. Okay, and we can also use the integer or tuple. So let's take a look at the examples. Okay, here this is you will see this is interesting. Okay, so arrange we already learned, so it's generate numbers. So here we have 10 numbers, is that 10 numbers, and it's 0 to 9, 0 to 9, and then you're going to do a you're going to here is it's the power of 3, is it, for each of the items. So that's how we come with the result. It's 0, 1 to 27, is it, all the way to 729. So this is the one-dimensional NumPy array with 10 numbers. Okay, then next let's take a look. This is interesting. So this is the array you specify. And here is what? Here is, it says it's another, so within an existing NumPy array, you put another NumPy array, is that ND array? So A is array already, and within here is a square brackets, is it? And because generally if we do just A0, then we know we are going to get the first number, is it? And A3, then we are going to get a 0, 1, 2, 3. Then we are going to get 27. So this is indexing. We know that, as we already know. But here, let's see. Here is a NumPy array. Is it a NumPy array? Okay, it says NumPy array. This NumPy array is created with what? With a list. Because here we have square brackets. Is it? So this NumPy array is 1, 3, -3. Okay, so it's an array. And you then put it to regarding this NumPy array. So what does this mean? So basically, this is still indexing, but it's just multiple items. So indexing for multiple items, not a single one. Like this is single one. And here you put within a square bracket and separated by comma. Okay, so it looks like an array. And then basically it's an integer array, etc. Then this serves the purpose of what? Of indexing. Okay, and we can take a look at the result. So here is 1, 3, -3, etc. Okay, 1, that means you're going to get to the second item. 3, the fourth item. -3 is what? And we already know Python allows negative indexing. Negative is the count from end, from back, etc. So the reverse counting, the third one. So that's this 343. So the result, if you take a look, yeah, it is this result, what we get. And you assign it to a new array, okay, to a new array. And then, and here also be careful, we are going to see, okay, next. So this is involved, we need to be careful here, okay? So whenever you do a NumPy data array, so this create a new array. Etc. And then we do indexing. And the indexing and the slicing, if you recall, it's operator on the original array. So basically on the reference, on the array reference. Okay, and then let's see. So this over here we specify ARR0. ARR0, what here we see the result is this. So the 0 is the ARR0. The ARR0 initially you assign it to what? You said -2000. Okay, negative, so this result will be changed. Okay, so after you, because it's on the reference. Okay, here. And then, let's see here. So for this one is on the original. Is it? On the original. On the original, what we see is this is slicing. Is it slicing from the beginning? Okay, slicing from beginning. But the step is 2. So every 2, is it? So you're going to have 8. Then you're going to have 64, is it? So 0, 1, 2, 3, 4, 5, 6, is it? So that's what we are supposed, but not included. Okay, so this one not included. And what we are going to do, you're going to assign the respective element to -1,000. To -1,000. To -1,000, then the output, if we take a look, you will see. Yeah, it did. So the respective value did get updated to -1,000. So the operation, so the slicing result is still on reference. Slicing. So that's why after you reassign, it impact the original. Okay, impact the original. And in sub 9, okay, that's the last item. Okay. And then next, let's see. What then this mean? Okay, and normally if it's 2-dimensional, then that means, okay, for the first dimensional, we take everything. For the second dimensional, we take indexing. So the first is in slicing. So for everything, going to include. But here, this array itself is one dimension. So if you have write something like this, then it's equivalent to you just do the single indexing. Okay, single index. So that's why we get this result. Okay, and over here is basically it's you do slicing everyone. So basically you get the original array. So that's the output is this. Okay, so this is regarding indexing and slicing. And then next, let's see what this means. This is slicing. This is slicing, okay, from the beginning to the end. And what? The step is -1. -1 is count from the end. So basically, if you want to reverse an array, you can borrow this idea. That you just put with indexing and the step as -1, then you can reverse an existing array. Okay, so that's regarding indexing. And the next one, later on, we are not going to use this from function. So let's skip that. But if you are interested, you can take a look. So from function, maybe because here we may need to explain a little bit. So anyway, so this is a Numpy function. It's called from function. So the first one, you need to plug in a function. The second one is the shape of the array. And the third one is some arguments, okay. So default argument here says, okay, it's going to be integer, something like that. So anyway, use this, you can also generate array. Okay, so here it shows, using this, generate this array, and it directly apply this function. So within a function, you plug in some other function, and then you let each element be generated according to this rule, and with this shape of the array. So that's what this method means. So anyway, array B generated looks like that. And let's see for this part. Okay, so still the same thing. And in other programming language, if you recall, you may also learn the lambda expression, etc. So in Python, it's similar. And we can also do the lambda expression, okay? So, but in Python, if you want to do lambda expression, because for this function, it's supposed to plug in a function here, etc. And here you can also, this kind of like inline, etc. For this lambda, and the function doesn't have a name, etc. And for Python, then you need to explicitly use the keyword lambda, okay? And the following it is parameter. This is a parameter, and then colon, etc. And then whatever the operation for the function is. So basically, this is a function, but just without a name, etc. So we call it a lambda expression. It's kind of serves as an inline function, and pretty efficient. So here, similar, that if you use lambda, you can also generate the array. It's a similar concept. Okay, anyway, so this array B is a 2-dimensional. So 2D array. Okay, 2D array, then let's see this. So this is regarding array B. Is there, within array B, then we have something like a comma. So before comma, what we do? This is slicing. So that's regarding first dimension. So for first dimension, we are going to do slicing. So first dimension is the row. Is it of the rows? We are going to do slicing. And for second dimension, what we are going to do? We do indexing. So this is the second dimension. So that's how we retrieve all of these items from the second column. Okay, that's what this part means. So we can see it's quite flexible. Is it? So in NumPy array, we don't need to write any loop to deal with all of this. And this is the same thing. It's just a bigger 2-dimensional array, 6x5 array. Okay. Okay, with this 6x5 array, then let's see. And previously, all we show is just one dimension we do slicing, the other dimension we do indexing, and you can also do slicing for all of the dimension. So here, let's see, you separate it by comma. So this is slicing for first dimension. And here again, that slicing for second dimension. So for the first one is count by row. It's starting from the second one, is it? So 1, 2, and the 3 not included. So we should take this 2 row. And for the second dimension, so this is second dimension by column. Is it? Here says for second dimension, we are going to include everything. So that's how we come with this result. Okay. So this is regarding indexing. This is quite useful. Okay, indexing the slicing for NumPy array, because in machine learning, we may also need to get some data. Then we can also use this concept. And what the next one try to show is that when fewer few indices provided, then the number of exits, because array B is 6x5. Suppose 6x5 is a 2-dimensional array. Okay, and over here, then you, because for 1-dimensional, if you just do this is called indexing for 1D. Then if you just do sub I, then it's indexing. Is it? And for B is a 2-dimensional array, but you're supposed to provide the comma. Is it? So this is regarding first dimension, and this is regarding second dimension. Is it? So over here, but we just provide one. Is that so? Here is as the missing index is considered the complete slicing. Okay, complete slicing. So here is as the result we are going to retrieve. Is that is the last row, because the second dimension we didn't mention. It's kind of is it the missing. Then it's just everything. Basically, this is equivalent to you write as -1. There's all the comma, etc. Or the 3 dots. So anyway, you can also write like this. It's just the ones that you didn't provide, etc. So kind of those parts are missing. So then they are just complete slicing. It does the slicing. Okay, so that's what this specific kind of syntax it is. Okay, then next let's take a dot dot dot. Basically, we already see the dot dot before, but still let's see. And so here is a, be careful, let's take a close look of this. This is not a 2D, okay, if you take a closer look, because you have one pair of brackets, then comma, is it? And if you take a close look, you have second bracket and also comma. So this is second pair, because within it, you have comma, okay. So then we have this second level of square brackets and the comma. And if you take a look further, close look, you will have the outermost brackets. And within it, you have the bracket separated by comma. So even though it looks like today, it's not, it's a 3-dimensional array. Okay, it's a 3-dimensional. So if we said, okay, we want to know the shape, is it? So let's see. The first dimension, is it? The first dimension, we have this one and this one. Is it? We have 2 left. So that's how the first dimension is 2. The second dimension, within the first dimension, so then we have this 2. So this is the second dimension. Is it? And the third dimension is by color. Okay. So that's how this 3-dimension looks like. Okay, looks like the shape. And then you say see. Then you do that. What is this? This is kind of weird. Is it? And we already learned this. This is what? This is to do indexing. Because what? Because there is no slicing here. Is it? So that means, okay, you want to get from the first dimension, we are going to get the second item. So this is the first dimension. And then for the second dimension, we are also going to get the second item. For the third dimension, we are going to 0, 1, 2, 3. So this is from the third dimension. So that's how you locate this single item. Okay, 113. Okay. So this is regarding 3-dimensional, we do indexing. And we can also combine indexing and slicing together. Okay, together. So this means for the first dimension, so this is the first dimension. We are going to get the second one. Second one. So this is first dimension. And then for second dimension, we are going to get everybody. Okay, so second dimension, we are going to have all the 2 rows, kind of. Okay, and for the third dimension, we are going to include everyone. Okay, so that's how come the result looks like this. Okay, so this is indexing plus slicing. And then similar here. This is just the last dimension. Is that the last dimension, you're going to get the third one. For the first 2 dimensions, you're going to get everybody. Okay, everybody. So let's take a look how this result is a result matter. Okay. So for the last one, we are going to get from the everybody. So 213, 102, and 113. So that's the last one. For the first 2 dimension, what we are going to get? We are going to get everybody. Is it? Okay, so you're going to get everybody. But the result, if you take a close look, it's reduced from 3D to what? So reduced to 2D. That makes sense, is it? Because you only do indexing for 1 dimension, and you do the slicing for the remaining 2 dimensions. Is it? So you can reduce from 3 dimension to 2D dimension. Because later on we will see a lot of time if you want to select a certain range of data, this is quite helpful. Okay. And then let's take a look the other one. So this is one, yeah, this is also 3-dimensional, is it? So we have, this is 2 by 2 by 3, the array B, is it? Array B is 2 by 2 by 3. And then what we want to get, and here it just shows all dot comma, is it? All dot comma. And over here, the last dimension, you're going to get, that's what we are going to get from the last dimension. Is that for the for the other two dimension, we are going to get everybody. So that's how we come up with this result. It also shows reduce from 3D get reduced to 2D. Okay, 2D. Okay, so that's this. So today we don't have enough time to complete this Numpy study. So we will continue next Monday.